Well, good news. The powder coating place called and said that the heat sinks and covers for this receiver were finished. So I went and picked them up the other day, and they really turned out well. These look absolutely brand new. I just cannot believe how well they turned out. And as I asked, he masked off the machined surfaces for the transistors so that they don't have any paint on them or anything. And these are ready to go back into the amplifier. I couldn't be happier with the way they turned out. Now, as I promised you earlier, we're going to have to deal with these thermal insulators. The ones that we removed are a special design. They're not something you can order. You're going to have to make them. Or you're going to have to be really careful like this and take very good care when you remove them so that they're reusable, so you can reuse them. The problem is mica will delaminate, and you'll get those little bubbles inside there, or it'll split apart, or it will very, very easily crack. And once you do that, it's ruined. You can't really use it. It either is going to be less efficient, or it's going to allow the amplifier, the transistor, to make contact or short with the chassis here, with the heatsink. So what we're going to do is we're going to make some new ones, and I'm going to show you how I do it for these. And because this is a skill you're going to need to know if you're going to work on this type of thing, because there's a lot of oddball parts out there that have oddball thermal pads that are not that easy to buy all the time. And even the ones you can find aren't always the best material for what you want to use. So here's what we're going to do. First thing is I'll show you what kind of material I'm going to use. I've chosen, well, I bought this straight from Mauser. So it is something that, you don't have to go to some strange source to buy. And here's the Mauser part number right here, and here's the actual manufacturer part number. This is made by Bergquist, and this company right here is very well known for the thermal interface products that they make. So usually if you buy this, and this name sometimes is used to describe thermal interface pads, but it's not actually made by that company. So you got to watch when you buy this stuff online, because you really don't know what the properties of it are going to be. Now, this model, this SP400 material, it's a trade-off between thermal conductivity and durability. And you'll find that the higher the thermal conductivity that you get, the softer the material will get, and the more easily it will tear, especially when you put pressure on it from the transistors. So when you go to tighten those transistors down, they can actually kind of cut through, especially like if you're the TO3P or the TO3, those metal transistors that have sharp edges, and when you tighten it down, it can easily cut through the more expensive stuff, or the better thermal conductivity stuff. That stuff's usually reserved for like heat sinks on microprocessors and so forth. But you have to understand, a microprocessor is going to run at a much higher temperature, and it's going to give off way more heat than these transistors are. People get really worried about it, but believe it or not, if a transistor is properly biased, it's properly coupled to the heatsink, they don't get that hot. As a matter of fact, they'll never even hit 100 degrees Celsius, ever, in a proper operation. And if they do, you have bigger problems than that. Typically, these things are going to run less than 60 degrees Celsius. So the thermal material you needs to be durable, so that the transistor doesn't cut through it or short out or whatever. It has to be electrically insulating. So that's why I chose this. This still has a very good thermal conductivity coefficient, and if you look it up and you compare it to a sandwich of mica and then 2 layers of grease and so forth, you'll find out that this is still going to be far superior to that, and it's going to be every bit as durable. So that being said, let's open it up and see what it looks like, and I'll show you how I make these things. So it comes sandwiched in between two pieces of cardboard because this stuff is relatively delicate, and but not as bad as, and I'll show you some other stuff here first. So when I talk about thermal conductivity, we have this material here, and we have the material that we're going to use. And thermal conductivity, at least the normal SI unit, is measured in watts per meter Kelvin. So you have the surface area, the amount of energy transferred, and how, what level of energy we're talking about. So it's kind of weird, but that's how they do it, and that's a standard, and you just need to understand the bigger that number is, the more efficient that material is at transferring heat from one side to the other. Now here's the trade-off. The better the thermal conductivity of a pad, the more delicate it becomes. So this stuff here is 12.5 watts per meter Kelvin, and that's really good, okay? But the problem is, when you peel the backing off of it, it's feels like very, very soft silicone rubber. And in fact, it's very stretchy, and it can tear very easily. However, it has good compression quality, so if you press on it, it's not going to break down. And it does have good electrical insulating properties, but it can easily tear, especially when you have something, like a transistor, for instance, like when you have these transistors with metal tabs on the back, and you put them on like this. When you tighten this screw, if you over tighten it, this will actually press right through that and could cause it to rupture. So even though it's good, you have to get the proper amount of pressure on it. You have to be very careful, and they're not usually reusable because when you take them off, they'll have an impression on them. So not practical for what we're going to do, even though this has the best thermal transfer. This is a little bit less. It's somewhere around, I think, 4 instead of 12. So it's, this is 3 times more efficient. But again, depending on the type of grease you use and the thickness of the mica and the quality of the mica, this setup can be as little as 1.8 watt per meter Kelvin. So that's a lot less so this is a lot better than that, even though it's not as good as this. And I know I'm rambling on, but people comment so much about this on Audio Karma and on different forums about, the advantages and disadvantages of different types of thermal pads, but that's what it's about. The problem is you just can't buy this stuff already cut out into some of these weird shapes like this stuff. So we're going to have to make our own. So you can buy it in sheets like this. This is not super cheap either. It's the Bergquist, if you buy the original stuff, I don't remember the price because I bought it a while ago. I don't remember how much I paid for this, but I know it's not cheap. But if you buy it in quantities like this, it's still going to be a lot less than if you buy the individually cut pads. So it's a lot better to make your own. Now, how do we make these things? Well, the first thing I'm going to do is we want to make the linear cuts to cut this thing down to shape. And you can use a pair of scissors, and we will in some cases. But when I'm mass producing, because we need 8 of them here, I want to have a nice straight, even cut, and I don't want it to, my hands doing this while I'm cutting. I'm going to use this, and this is just a paper cutter. You can buy these at most office supply stores, even places like department stores like Walmart and Target and things will sell these. This is not a really high-end one. The ones that we used in grade school, 40 years ago or whatever, they were all metal and real heavy duty, and this was real thick wood, and but these work just fine. So all it is, you know, the old ones it looked almost like something you'd use in the French Revolution. But these ones work well. So let's get this stuff out and let's mark it to the proper size. Now this stuff has a peel off backing to it. So this side is the exposed, this is the actual material. The back part you can kind of see is shiny, and that's because this is peel off. Some of these have adhesive on the back. So they'll stick on, which is nice because it'll hold in place. It won't move around when you're putting the transistor down. Some of them are not. But mainly what this also does is this just gives a little bit of substance to this so it won't tear. Although this stuff is pretty, you can see up close. I don't know if you can get it in the light. You can see that it's kind of textured. This is almost like silicone. It feels more like rubber. This stuff is very gummy and stretchy, and it feels really soft. So that's the difference. So what I'm going to do is I'm going to take one of these pads like this, and I'm going to go ahead and just mark the width of it at the top and the bottom. So I'll just take a little marker here, and we just want to make sure we get this lined up properly. And I think one strip will get all 8 of these. So first thing we're going to do is I'm going to use this side down. I'm going to put this up in here like so. And I'm just going to make sure that the top and the bottom line up properly. Should be pretty close. And there it is. You can kind of see where we are. I mean, this thing's not cut perfectly square. That's why you can't just use the back of this, because these aren't perfectly square when they're the way they're cut. So we're gonna, all right, and we're gonna cut just like that. And of course, it's all messed up. Good Lord. So I'm gonna hold this down, because we were just kind of off the edge a little bit. This is all live, everybody. Okay. And there we go. Let me peel this off. Watch Tony screw everything up on camera here. I refuse to edit this stuff out. Just look at it as humility for Tony. And to understand that if you mess it up, you're not alone. You're in good company. Okay, now what I'm going to do is I'm going to close this, and I'm just going to go through and I'm going to mark each one of these for length. Just like so. Okay, so they're all marked for proper size. And I got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them out of there. So I got one spare, which is great. Now I'm going to take one of these thermal pads again, and I'm going to use it as a template to mark where the holes are going to go. So I will start at the end here. Get it lined up. Let's see where we're at. And this stuff sticks on here. There we go. And I'm just going to mark the 4 holes and the slot. And I'm going to do that to all 9 of them. So as you can see, I've marked all these out, and yes, using a felt tip pen on silicone is not easy. The ink doesn't like to flow very well onto it, but we got them marked. So there's several different ways we can go about punching these holes. So this first one is a leather punch. It's a little hole punch, and you can move these around and it will punch the different holes that you need. You know, you kind of squeeze and then kind of give it a twist. Sometimes these work really well with this. Sometimes it'll tear it a little bit. But you can use them. Just make sure they're pretty good quality. Another method is to get these punches that you actually hit with a hammer. You can see them. They come in all different sizes. And you just put them on a hard wooden surface, you know, and just punch it through, and those work. But I quite often, my wife is a absolute master at knitting and crocheting, and she's a wonderful seamstress, and she always goes to the craft store to get different supplies and materials, and I quite often will go with her there because the crafting community comes up with some of the most awesome inventions. And this is no exception. This is a hole punch for material. And you can see it comes with removable tips, like that. And when you push down on it, it rotates. And you get this little cutting mat that's kind of stiff and gives you a nice flat surface. And this seems to work better than any other method that I've ever tried. And I mean, this thing wasn't very expensive, but it just works. So we're going to use this. And what I'm going to do is I'm going to punch the larger diameter holes for the screws first. I'll change out the bit, and then we'll punch the small ones. And in these little slots, we're just going to make a little incision with a hobby knife in order to allow the tab. And you can see those are in there for this reason. The little clip that holds the transistor down has a tab, and that's what keeps everything centered over the heatsink. And that tab, as you can see, goes through that little slot, so we just have to make a little cut for that to go through. So I'll show you how this thing works. So you just line it up, just give it a quick push. Perfect. Now, before we move on, I'll show you what this is. These have a name. See that little piece that came out, the little punch? Those are referred to as chads. And in the 1990s, our wonderful news media in the United States decided to expand upon the definition of chad. So, for instance, this one that punched all the way through is a free chad. If I push this through and it cuts partially, but it doesn't cut the whole way through and it kind of flaps down, that is referred to as a hanging chad. If I don't push hard enough and it just makes a little imprint that pushes down the bottom, that is called a pregnant chad. And of course, we got into a big lather over these, and everybody was arguing over whether pregnant chads counted or not. And I was explaining this to my children one day, and one of them, and I forget which one, said, "Dad, that's not what the word chad means anymore. There's another meaning for chad. When we hear the word chad, there's a, you know." And all I said was, I don't want to know what it means. I don't want anything to do with it, but I'm sure you guys are still arguing over whether pregnant chads count or not. And I don't want to know that either. Anyway, I digress. Let's punch these out and see how they turn out. And see, this makes such a nice perfect cut without any effort at all. Oh, we have a hanging chad. There we go. Alright, so let me finish this up so I don't bore you to death with this. And I'll be right back. Okay, they're all punched out. And where did I put it? Let's see. Where did my hobby knife go? There it is. And I just used a hobby knife like this with this kind of blade. And I just made a little incision inside those tabs there. Now, I moved the camera a little bit to the side so I have a little better alignment than I did last time. So hopefully I will cut this straight. And all we're going to do is cut these down to size now. Just like so. You have to kind of go quick so it pops through it. And there they are. Now, if you really want it to look professional, you can get a little piece of paper towel and soak it with some alcohol, and you can just wipe that marker off there if you want, because alcohol dissolves that pretty easily. And just, you want it to be clean. There's one. And I was kind of running that marker around there, so it did imprint that part a little bit, so some of that is just an indent that you're looking at. So I'm just cleaning this off. You don't want any dust or dirt or crud on there. Feel free to skip ahead if you don't want to watch me do this. I like watching paint peel sometimes. You know, I had a friend in high school, one of my best friends, and he came over to the house. You know, typical high school kids, nothing, don't know what to do, bored. And I'm like, hey, what's up? And he's like, I just spent an hour watching the clock go around for 1 hour just to see what it looks like. And I'm like, okay, that's a new level of boredom. He's like, yes. But he says, now I know what it looks like for a whole hour for the clock to go around. I'm like, well, that might be some important knowledge to have one day. I don't know. So, yeah. Ever been bored like that? I sure have been. But, okay. And there they are. Let's see if they fit. Okay, for the moment of truth, let's see if I can peel this off. Peeling backing off of stuff like this is one of my most frustrating things to do. I don't know if you ever bought any of those little kits, little, you know, oscilloscope kit or a little whatever electronic thing you get from China. And they come with those little plastic cases that are in like puzzle pieces you put together. And you have to assemble them. And they're made out of acrylic, so you have to peel that backing off of it. And I'll tell you what, I hate doing that. That's just, sometimes you could put a piece of tape on it to get it to start, but quite often it's just misery, like this is. There, I got this one. And the idea with this stuff, it is kind of delicate, so you can't get too out of hand with it when you're trying to peel it, or you'll tear it. But there it is. And that stuff is really on there tight. This is the adhesive backed stuff, so once you put it on, it's permanent. So we want to line this up with the holes and pop it down on. And look at that. Perfect. And that will do a great job with those. So let me remove the peel off stuff off the back of this so you don't hear me cussing off camera. And I'll put the other ones on and we'll see what it looks like when it's done. Okay, there's the finished product. Now when you go to assemble these, you have to be very careful you get it in the correct orientation, because there's a left and a right, and of course there's an orange and a red. So the orange one, if you're facing the front of the receiver, is going to be on the right hand side. And so you want the pots to face up. So you got to get this in there the right way. So in other words, if the front of the amp is facing this way, this would be the right side, and it would go like this. So therefore, when the board is mounted, you want these pots to face this way. So this is how the transistors have to mount. So we're going to flip this around, and this is the way it's going to go. I don't want to have to do this over again because I got it upside down. It's easy to do because they're opposite of one another. So the other channel is going to be flipped 180 degrees. The heat sinks are identical, and the amplifier modules, other than the colors of the wires, are identical. But how you mount them to this, these heat sinks are made that you can mount it either direction. All right, so let's get the first one of these here. And what I'm going to do is I'm going to take one of these and place it on here. And the first one's going to be really awkward to get started because everything's kind of moving around on you. And I'm going to take my grandson's screwdriver that he bought me for Christmas, and I am going to place this in here. And then I'm going to find all the missing hardware that fell apart. This is just so much better than all that grease and the mica that cracks and wears out and peels. And this is a one and done thing. And you can see that little tab pops right through that little slit that we made. And I'm not going to crank these. I'm just going to have them loosely in there until we get the other side down as well. All right, so I'll grab another one of these, and I'll try to clean off some of the schmutz that's on these too, because, well, don't have to, but it just looks better, right? I normally don't go to crazy extremes on these like this, but this receiver warrants it because they're hard to find. This was one of the highest end receivers that Pioneer made at this era. I mean, the only bigger one than this would be the SX-1280. So I really want this one to turn out perfect. There's not a whole lot of good examples of these that are cosmetically perfect. So when you find a nice one, you really want to make sure you take as good a care of it as possible. Like I said, I want people to be able to use this thing 30 years from now and experience what this technology was like back then. And unlike the mica, you really don't have to crank these down very hard. They have lock washers on here. It's not going to go anywhere. And it'll make really good contact. And there you go. That's the first one. I'll go over and do this one. Like so. Same process. And again, we can modify. Actually, I think it's safe to mention this, but if you recall, oh, it's been years now, I restored a Adcom, what was it, GFA 585, I think that was it. It is a big 250 watt per channel amplifier. And it was a very comprehensive restoration because it was one of the original generation that had capacitor blight. And that capacitor blight soaked into all the boards and ruined them. And there was a company called Hoppy's Brain, Hoppe, and it's run by a gentleman named Chris Hoppy, who is a very brilliant person who comes up with a lot of really innovative ideas, for things like this where you can't find parts and things anymore. And he came up with these boards to replace on that amplifier. He has a whole series of the Adcom replacement boards. And anyway, he emailed me the other day and asked if I was interested in working with him on making some adapters that'll allow you to use a modern transistor as a drop-in replacement for these. And I jumped on that opportunity, and I think that'd be really cool. So we're going to do that, and if it works out, we may have a solution for these transistors when they fail, that we can actually replace them with something better. So I'll keep you posted as we progress with that. Okay, so that takes care of the amp modules, and they turned out really well. They look brand new. I'm really pleased with the way these heat sinks came out. So that completes that part. Now, I did do some additional footage of preparing the chassis and replacing the big filter capacitors. So these have been replaced with new ones, and I'll either put that on a separate video or I'll append that to the end of this one, depending on how long this video turns out to be. So as always, I wish you all peace, joy, happiness, and good health in your lives. And this project is coming along really well, and I'm really excited to see how it turns out. All right, everybody, stay well, and we'll see you again real soon. Bye-bye.